Good evening, Mr. Goodstein. First, we're going to talk about meiosis and mitosis. The first stage is the interphase. The first stage, interphase, is the phase before the cell divides, when the cell copies itself. This happens in the nucleus. Next phase is the prophase. So this step is the prophase. This is when the identical chromatids, the sister chromatids, line up next to each other. When they're lined up next to each other, they make homologous chromatids. The next step is metaphase. This next stage is metaphase. This is when the sister chromatids, those identical things right there, 1 and 2, that is when they line up in the middle of the cell. And the DNA is in the middle of the cell, and the spindle fibers are pulling from the edges. The sister chromatids are held by the spindle fibers. The next step is anaphase. This step is anaphase. So, in this step, the sister chromatids are pulled apart as shown here. Okay. And the spindle fibers move to other sides like opposites. So, there's some here on this side. There's some here on this side. Next step is telophase. So, yes, this step is telophase. The telophase is when the sister chromatids finally get to the end of the cell and the new nucleus starts to form. Okay, so the new nucleus starts to begin making itself, and the cell starts to split apart, and the spindle fibers are not there anymore. They are gone. Congratulations! We finally reached the cytokinesis. This is when the cell splits, and the new nucleus are in each cell. Would you like? Okay. That is the new nucleus in each cell. So, yes, and the spindle fibers still are not there. They are gone, done, finito, kaput. Is mitosis. But let's move on. Before we move on, I'm just going to say something. The final cells in mitosis, are identical to the final cells. Okay, sorry. Let me rephrase. The final cells, the two final cells in mitosis, are identical to the first cell in mitosis, which is interphase, and they are the exact same thing, just two in cytokinesis. Now we can move on. Now we are going to talk about meiosis. Okay, in mitosis, it's basically it has the same stages as meiosis, but just two of most of these stages, except for the interphase. So, the interphase is the same as mitosis. You have this stage before the cell has divided, where the DNA copies itself. The interphase. Next step is the prophase 1. These two in the prophase 1, those are homologous chromosomes, abbreviated as HC. And each single little each single line, which is part of the X, is a sister chromatid, which can be abbreviated as SC.
But there's still one.
Is it? Oh. I really don't think we need to go through all of these steps of meiosis. So I will kind of just explain what happens. So basically, it is a lot like meiosis. So there's the homologous chromosomes are still lining up in the middle of the cell. Okay, and they line up in the center in metaphase 2, and okay, metaphase 1. I mean, so basically, then what happens is the 1 second, please. I'm sorry. The cell begins to split apart again, and then the sister chromatids pair back up again, and this is basically the same, identical to mitosis, except the homologous chromosomes are in the separate cells. So now, but after the sister chromatids line up in the center, they are pulled apart. Isn't that a shame? I think it is. I think sisters are meant to be together. Okay. But then the new cells, this, like this, these will pull apart and make 2 cells each. So now you have 4 cells, and it looks like 4 cells, and you have 4 new cells. And that is different from mitosis because you end with 4 cells instead of 2, and well, they are actually similar to the interphase in meiosis because they each have their nucleus and they're each a cell, and that is meiosis. Yes, all of the cells, the 4 new cells that are made are they're all identical to each other. You can't even tell them apart. Now, what do you think happens when you reproduce via mitosis? Well, I will tell you. When you reproduce via mitosis, that is asexual. Sorry, my bad. Okay, I'm sorry. So anyway, mitosis is reproduction of asexualness, and if you're reproducing using meiosis and fertilization, that is sexual reproduction. So, yes. So you could say mitosis is A and meiosis is S. Okay, so now we are going to talk about some environments where sexual reproduction and asexual reproduction like succeed the best. Okay, so one is when there's for sexual reproduction is when it's a changing environment. So
a starfish could be another one.
So wait 1 sec. An advantage of changing environments is that you can adapt. An environmental condition for asexual is when you have a harsh and empty, unchanging environment. So, an advantage about this is that it's the speed that really helps. So you can make more kids in less time. That is surprising. And another advantage of the changing environment is that you will have 2 parents. And also for the asexual reproduction in a harsh, empty, unchanging environment, there you don't have to find a mate and spend energy finding a mate. So I'm going to give you some species that use the forms of reproduction. So you can take the brittle star for an example. So It actually reproduces both ways. This is a Bristol star, and yes, it does use both types of reproduction. So the reason that it uses both types is so it doesn't have to use lots of energy to reproduce. It's non-mobile, and so it can adapt and evolve. Next, we have the desert grasslands whiptail lizard. It reproduces asexually. The reasons that this will reproduce asexually is so it is in a harsh desert. It will be hard to find a mate. You caught that? I will say it again. The good reasons is it will be in a harsh desert. It will be hard to find a mate, and it can lay more eggs. So that's why it reproduces asexually. Lastly, Josh, I would like to thank you for watching my Doodlequiz. Remember, I'm your favorite student.
Made with Doodlecast Pro.